Hi, in this video we're going to be assembling this PCB. So this is the board that I had made by JLCPCB for my lighting controller project, and I also had a solder stencil made for this board as well. So what we're going to do is we're going to apply some solder paste to the PCB through the solder stencil, and then I've re-rigged up the pickup tool so that we can place the parts on there, and then we're going to use the Pros Kit SS969 hot air station, which I did a teardown in a recent video on, to see how good this is, and also to obviously reflow the parts on the board. So I've been ordering a couple of different types of solder paste. I think we're going to give this one a go. This is Best solder paste. So this is actually from Banggood, but I bought this one just to see if it's any good, really. I normally order the Electrolube solder paste from Farnell, but it's quite pricey. And it does tend to expire relatively quickly, so unless you're doing loads of work, it actually works out quite expensive. Right, so the first thing I've done is I've just put one of the boards on a sheet of MDF just to protect the bench, and I've taped the board in place, and we're going to try and place the stencil on top now. And we want to get that really well lined up, so just take a moment or two just to check the fine footprint parts to make sure that it's all lined up properly. Right, so I think that's really well lined up. Sorry, the lighting is going to be really sketchy because it's just reflecting straight off the stencil, but I think that's well lined up. And what I'm going to do now is I'm going to apply some of the solder paste. We're going to use this solder paste instead. I had a quick test with the compressed air on the Best stuff, and it's too thick at the moment, so I think it's just a little bit too cold. This one's flowing better, so we're going to try this mechanic solder paste. And then we're going to apply some over the board, and then squeegee it over and then lift the stencil off. So let's see how it goes. Now, if you were to do this properly, you would have a whole bead of solder paste at one end, and it would just be squeegeed in one go. But I don't want to waste too much of the paste, so we're just going to do it like this. Right, so just give it a once over and just check that you've covered all of the parts. That looks pretty good. So what we're going to do now is just try and lift the stencil straight up and off the board. And there we go. I think we've got pretty good coverage there. Okay, and I'm just going to repeat that 2 more times because we're going to build up 3 boards. I've got 3 of these DSPIC 33s, so I may as well build them onto boards so they don't go and get lost somewhere. Right, so once you've applied the solder paste, just give the PCBs a quick inspection. They're mostly okay. You can see I smudged this one very slightly as I lifted the stencil off. It's up to you what you want to do, really. You can clean the board off and just start again. It's not really a problem. I'm going to leave it as it is and see how it turns out. And if it goes wrong, then this will be a nice video to show you how to tidy things up by hand. This one's looking also very slightly light on some of the pads. With solder paste, this one's looking very slightly over applied on here, so yeah, we'll place the parts, and when we do the hot air rework, we'll see how these turn out. So next, just give your stencil a quick clean so that you're not risking putting solder paste everywhere, because it can be quite nasty stuff. And then what I'm going to do is set up the microscope, and we'll place all of the parts. Right, so to begin with, we're going to start with the power supply section here. And what I've done is I've just laid out all of the components on a sheet of A4 paper with a bit of double-sided sticky tape, so everything's ready to place. So I'm just going to, place all the parts with the pickup tool. Let's see how it goes. Right, so to start with, I'm just going to touch up the big capacitors with the soldering iron, because it's a bit of an ask for the hot air station to reflow these. Obviously, if we were doing this in a hot air oven, the whole board would be brought up to temperature, but there's no thermal reliefs on these pads, so we'd have to heat quite an area, and there's a good chance that the plastic at the bottom of the capacitor would probably melt. Right, so now we can start heating these up with the hot air station. So the hot air station is set to about 380 degrees. It's a little bit higher than what you'd normally reflow the whole board at, but that's because we're doing it with hot air. We're going to lose some of that temperature just in the distance between the hot air nozzle and the PCB. And also we haven't got all of the board up to temperature. You can reduce that temperature if you have the board on a plate preheater, but I haven't got one of those, so we're just going to go with a slightly higher hot air temperature. Next we can move on down towards the microcontroller, and we'll just start with the capacitors around the microcontroller just to get the board heated a little bit. And there we go, so that's the board done. We'll give the microcontroller a slightly closer inspection. I think there may have been a little bit too much solder paste on this particular micro, so we might need to just reflow it slightly with the soldering iron. Right, so just looking at this particular board, the other two were okay, but this one's got quite a few solder bridges. I think this was the last one and I probably applied too much paste. So what we're going to do is apply some flux paste to the pins and then drag the soldering iron along the pins to hopefully try and drag the solder away. If there's too much on here, I think we'll just have to use a bit of solder wick to get rid of the excess solder. And then just to clean up, use a tissue and some flux clean. So just place the tissue on top, give it a good old spray, let it soak in for a minute, and then use a brush. And the tissue is quite important because it soaks up all of the remaining flux residue rather than just sort of spreading it over the board. So some people just spray the flux cleaner and not actually remove it, and you end up with residue all over the PCB. It just sort of dilutes it a bit as it spreads. But here you can see that looks a lot cleaner, and we've not left loads of residue all over the board. It's a little bit just over here. There we go. Right, so there we've got 3 PCBs ready now. I just need to put the through-hole parts in, but those are ready for the lighting controller project. And I just wanted to show you really the process for using the solder stencil, the solder paste, and then placing the parts on there. Obviously, you would normally try and reflow these in the more normal way of heating the whole board up and following the reflow profile. That means you don't have to have the temperature anywhere near as high as you have to with the hot air station. And the hot air station worked really well. That's the SS969, which I did a video on previously. I've got no complaints about that. That seemed to heat up no problem. But what tends to happen is you have your hot air blowing in an area, and then there's going to be a gradient of temperature spreading out across the board. And it just means that components like these big capacitors, you're never going to be able to reflow properly because you haven't got the heat from all direction. You're only going to be able to circle around them. You're not going to be able to get underneath them where the pads actually are. So with those, you're never really going to manage that well with the hot air station. But certainly for standard surface mount parts. You saw it reflowed the regulator and all the 0805 components fine, even did the crystal okay, and then obviously the processor was fine as well. So hopefully you enjoyed that video and maybe learnt something. Leave any comments down below, good or bad. In the next video what we're going to be doing is assembling the trailing edge dimmer PCBs. I think those are mainly all through-hole parts, so it should be a little bit more straightforward, just standard soldering iron work, and then what we'll be able to do is link them up and actually do some testing with that. But yeah, leave comment down below and subscribe if you haven't already. But until next time, thanks for watching.